Okay, at the top, they gave you the parent function for sine and the parent function for cosine, and they marked some critical points. So we are going to transform these, and we will use what they give you, 1, 2, 3, 4, 5 critical points each. We'll use the 5 critical points in order to help us sketch the correct transformed graph. So, if I look at my first one, they've got a vertical stretch of 2 on both sine and cosine. So we are going to transform both sine and cosine with a vertical stretch. So it's a vertical change only. So if you look, first we'll fill in this A, B, and C. That's your A value. There's no B value listed, but B is always right in front of X, so it's 1. It can't be 0 or there would be no X there. Does that make sense? Because 0 times X would make it 0. There's no C value. And there's no D value. Okay, so I have a vertical change only. So if I look at my 5 critical points, the only thing that's going to change in my 5 critical points is the Y value, because this is just a vertical stretch. And a vertical stretch is multiplying by your Y value. So that's all I'm going to do. So my X values are going to stay the same. So this first point on sine is still going to be 0, 0, because the X value doesn't change. And if I multiply the Y value by 2, 0 times 2 is still 0. So my first point is still 0, 0. It's right there. So far, everybody okay? Mm-hmm. Okay, so my second point, pi over 2, 1. The pi over 2 doesn't change, because this is not a horizontal change. But the 1 becomes 2, because I multiply my Y value by 2. So it's pi over 2, 2. My next critical point, the X value doesn't change, because this is just a vertical change. I multiply my Y value by 2. 0 times 2 is still 0. My next point is 3 pi over 2, negative 1. So the 3 pi over 2 part doesn't change, but the negative 1 becomes negative 2. And then 2 pi is 0 is still 2 pi 0. It doesn't really look any different, and the reason why is because they scale it differently. I wish they hadn't, but they did. So we're going to do, is everybody good? Mm-hmm. So we're going to do the same thing for cosine. It's still just a vertical change. So it's only affecting the Y values. So I multiply my first Y value by 2. My second Y value by 2. Everybody all right? It's not too bad, right? Okay, so the next one, I still have a vertical change. This time it's a half, so it's a vertical compression. You're still just multiplying your Y values by whatever the vertical change is. So this is a half. So my X values aren't going to change. Let's see, 1 half, 1, 0, and 0 are my A, B, C, and D. Just real quick, does everybody know where I'm getting these? I'm using this, and your A is in front. Your B would be right in front of X, and I don't have anything, but it has to be 1, or there wouldn't be an X there. There's nothing with C, and there's nothing with D. Okay, so my first value, which is 0, 0, is still going to be 0, 0. Now this one's going to be pi over 2, and I multiply my 1 by a half. So this is going to be pi over 2 and a half. So it's going to be right here. So this one is going to look different. So it looks like that. Because this one has been vertically compressed. Everybody all right? Easy, right? Okay. So same thing with cosine. Okay, so that's how does the A value affect the critical points of the overall graph? It is a stretch or compression. Vertical stretch or compression. Okay, now we're going to change our D value. Now, if you remember yesterday when we took our notes on the D value, remember we said if you know D, it is the central axis. It is the midline of the graph. So one of the things that I think makes it easier to do the graph is if you know your D value, if there is one, go ahead and do like a little dotted horizontal line there, because that's where your axis is going to be, which means your amplitude is going to be above and below that. So I think it makes it a little easier. So in this case I have sine plus 1. So has your A value changed in this one? No, your A, and so your A value is 1. It has to be, because if you had a 0 here in front, that would get rid of the word sine. So it has to be 1. That's your amplitude. And the amplitude of the original sine and cosine wave is 1. So it goes up 1, down 1. Hadn't changed at all. My B value is still 1 because I still have an X. My C value is 0 because there's no horizontal or phase shift here. And my D value is plus 1. Which means I have a central axis at 1 on both of these graphs. Now, if you're using your critical points to graph, it is a vertical change only. So again, your horizontal values or your X values on your 5 critical points aren't going to change. Your Y values, you're adding 1. So my first point, instead of being 0, 0, is now going to be 0, 1. My second point, the pi over 2 doesn't change, but the Y value, I add 1. So instead of being 1, it's now 2. Pi 0 becomes pi 1. And 3 pi over 2, it was negative 1. Well, when you add 1 to that, it becomes 3 pi over 2, 0. And then 2 pi 1. Looks like that. And we'll do the same thing for cosine. It's a vertical change only. Your X values aren't going to change. Your Y values, you're adding 1.